3.1 quadratic functions and models. A polynomial function of degree n takes on the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a sub 1 x to the 1, or just x, plus a sub 0. So that's just saying, depending on whatever the degree is, that's how far out you go as to whatever the highest degree is. Typically, we're dealing with degree either like 0 to 5 or 0 to 4, sorry. So I'm just going to write out what the names of those are. It's not really relevant to the actual homework, but it will be relevant later. But it basically, whatever the degree is, that's how many zeros there are. So you'll need that later in the chapter. So the function type and then we're going to have degree n. So a constant function has degree 0. It's just a number. Linear is degree 1. So that's like the graph of a line, y equals mx plus b. Quadratic, which is the one that we're dealing with in this section specifically, is degree 2. So it's like ax squared plus bx plus c. The next one is cubic, which is degree 3. So that's going to be, if you looked at this form up here that we wrote, everywhere you would see an n, you would write a 3 until you get down to just a sub 0. And the last one is quartic, which is degree 4. So we're going to be dealing with the quadratic function in the form f of x equals ax squared plus bx plus c. So this would be standard form. The next one I'm going to write is vertex form, but it is the same thing, just written differently. F of x equals a times x minus h squared plus k. That's in vertex form. And a couple things to note in this form. If a is negative, it is reflected. So the graph would be reflected. If the absolute value of a is greater than 1, it's stretched. Absolute value of a is less than 1, it's compressed.
You do this in pre-calc?
Yeah. And Algebra 2. That's what I'm about to teach in Algebra 2, so that's all I know. So I start tomorrow with them. Inside the parentheses, okay, the h value tells you to move it, or let me rephrase. Inside the parentheses, I need to rewrite this. I cannot get my words together. Inside the parentheses, the h value moves opposite the direction of its sign. So in the form, the way that it's written, it's minus h. So this would be moving to the right h. If it was plus h, it would be moving to the left. Outside the parentheses, the k value moves the same direction as the sign. So positive k, the way that it's written, moves up, negative k moves down. So if you're given standard form and they want you to get it in vertex form, or if you just want to find out things about the graph in terms of how to graph it, because without just plugging in points and plotting them in standard form, you probably wouldn't just know what that graph looks like. So we need to be able to translate it to vertex form. Can't talk. So how to get from f of x equals ax squared plus bx plus c to y equals k, and y or f of x, they mean the same thing, doesn't matter, equals a times x minus h squared plus k. So I'm given standard form, I want vertex form. To find h, I would do minus b over 2a, so I would take the number values, okay? If the signs are there with them, the sign goes with them, okay? So it would be minus b over 2a, and k is equal to f of h. So we would take and plug in minus b over 2a into f to find k. So you could also write this as f of minus b over 2a. So some stuff about the characteristics of the graph. First, it's a parabola with vertex hk. Now, it's hk assuming it was given in minus h plus k. Okay, if it's not written this way, then you've got to fix the sign that's on here. Okay. And the axis of symmetry, which I will usually write as AOS, is a vertical line that's x is equal to h, which is minus b over 2a if you had been given standard form. It opens up if a is greater than 0, or down if a is less than 0. 3 gets wider if the absolute value of a is less than 1, and narrower if the absolute value of a is greater than 1. For the y-intercept, because typically when I graph, I'm looking for the vertex, axis of symmetry, and then I'm trying to find the y-intercept, and then thus able to find the other point on it because of the shape of it. Whatever you do to one side, the same point on the other side, that far from the axis of symmetry exists, and so you can graph it with just those few things. The y-intercept is 0 and f of 0, or 0 in the point C, because we don't know what that would be. Or, well, let me rephrase. We do know what it is if you have standard form, because if you plug in 0 for x, those first two terms go away and you're just left with C. So that's how you would find it. 5. This one's a little confusing, so don't let it overwhelm you. It's not as hard as it looks. X-intercept is found by solving the equation ax squared plus bx plus c equal to 0. So it's just like solving a quadratic equation. So there's different ways you can do that. But under that, if b squared minus 4ac, so inside the quadratic formula, set this under the square root. Okay, if you did b squared minus 4ac, if it happens to be greater than 0, then the x-intercepts are, and I say are because there would be two of them, minus b plus or minus the square root of b squared minus 4ac all over 2a, and then 0. Okay, so the plus or minus is why there's 2. If b squared minus 4ac is equal to 0, then the x-intercept is minus b over 2a and 0. Then if b squared minus 4ac is less than 0, there are no x-intercepts. Okay, which is possible because the graph could be shifted like up and to the right or left, so it wouldn't be ever touching the x-axis.